Hi, this is Alex from devstories.eu. LangChain v1.0 Orchestration Framework, Episode 4 of 20. If you are still passing plain text strings to your language models, you are severely limiting your applications. Plain strings drop context. They cannot safely hold image references, tool execution results, or distinct interaction roles. To solve this, LangChain uses standardized message objects, acting as the universal language of LLMs. A message in LangChain is a data structure containing a specific role, the payload, and optional metadata. Different API providers handle conversation roles and multimodal inputs differently in their raw APIs. LangChain abstracts this friction away into 4 distinct classes. The first is the system message. This object establishes the background rules, persona, or strict constraints for the interaction. Next is the human message, representing the user's prompt or uploaded files. Then we have the AI message, which captures the model's generated response. Finally, there is the tool message. This object specifically carries the result of an external function execution back to the model, cleanly separating raw user input from system-generated factual data. You orchestrate conversations by passing an array of these message objects to the model. You can manually construct this array to shape the output. First, you create a list and insert a system message, assigning the model the role of a strictly formatted poetry expert. Second, you append a human message asking for a haiku about database migrations. Here is the key insight. You do not have to wait for the model to generate the next response. You can manually instantiate an AI message and inject it into the array right after the human prompt, containing a specific opening line. When you pass this entire array to the model, it interprets your injected AI message as its own past behavior. It will seamlessly continue the haiku from your exact starting point, adhering to the structure you forced upon it. When you eventually receive an AI message back from the model, you need to extract what it actually produced. Developers routinely confuse the raw content attribute with the parsed payload. Every message object has a content property. However, this raw content attribute directly reflects whatever the specific LLM provider returned. Depending on the model provider and the prompt, this might be a simple text string, or it might be a highly nested list of dictionaries containing mixed text chunks, image URLs, and tool identifiers. Parsing this manually makes your code incredibly fragile. Instead of reading the raw content, you should use the content blocks property. The content blocks property is LangChain's strictly typed, standardized representation of the message payload. When you read from content blocks, LangChain translates the provider-specific response into a uniform list of block objects. You can iterate through this list safely. First, you check if a block is a text block, and if so, you extract the text payload. Next, you check if it is a tool call block, and you extract the arguments. Building your parsing logic around the standardized content blocks property is the only way to ensure your application remains entirely decoupled from the shifting response formats of individual model providers. That is all for this one. Thanks for listening, and keep building.